Good day, viewers. You're welcome to another edition of Subject Math. Today we'll be talking about angle of elevation and depression. Now, angle of elevation and depression is not a new topic to you. But now we're explaining here. They said an angle of what? Elevation. This is a situation where a position at a higher point is being viewed from a lower point. Now, this angle of elevation is what? Like looking at a position which is higher from a lower point. For example, looking at what? The top of a building. Look at the top of my building while standing on the ground. And that is what? Looking at that top of the building is an angle of what? Elevation. For example, if I have a fence and I have a point A. Let's say this is my fence. This is my fence. I have a point A. Now, from this point A to the top of the fence makes an angle of what? Theta to the ground. Now, this angle theta here is what? Is the angle of elevation. So today, this is what we're talking about under this angle of elevation. Whereby we're solving enough questions from this. So if from this top, from this point, looking to this place, it's an angle of what? Elevation. Then what is the angle of depression? Now, angle of depression becomes from this point, let's say, angle of depression means what? Looking from the top to the ground. So if I look down, it is what? An angle of depression. And then when calculating for your angle of depression, it makes what? And this is your angle of depression here, your phi. So you can now say, okay, let's call it theta. Your theta here is your angle of what? Depression. Now if you are looking for the top, it's not going to be inside. So the internal angle here now becomes what? 90 minus theta. So this here is called your what? Your angle of depression. While looking from the what? Ground position to the top is called your what? Your angle of elevation. So I would like us to pay close attention to this because our questions is going to be coming from this particular circle. Now we have this. A boy flies a kite. We are going to be interpreting this question. A boy flies a kite with a string of length 50. Now if this is the kite, this is the kite. So he flies this kite with a string, okay? So fly this kite with a string of what? 50 meter. Now if the string makes an angle of 30 degrees with the ground. So this is the ground. The string makes an angle of 30 degrees with the ground, okay? Now they said, what is the height of the kite above the ground? Now this is the kite. What is its height above the ground? Let that height be h. Now, we've done trigonometry in the last class, so we're going to be using trigonometry a lot here. Now this is our opposite. This is our what? Angle. Now here is our opposite. And this is our what? Hypotenuse. Here is our adjacent. So I'm looking for our opposite. Now what relation is your opposite and hypotenuse? Sine theta is equal to what? Opposite over what? Hypotenuse. So sine here, that is sine 30 is equal to your opposite here is your h. Your hypotenuse here is your 50. At this juncture, sine 30 is equal to 1 over 2 according to your special angles. We did that in the last class. H over 50. So at this juncture, we what? Cross multiply. So cross multiplying there, we're going to have what? 50 is equal to 2h. So divide both sides by 2, 2 cancel 2. So h here is equal to 50 divided by 2, that is what? 25 meter. And that is our final answer. So the what? The height of the kite above the ground is equal to 25 meters. Now, look at this question. The shadow of an electric pole, 70 electric pole, this is the height of the pole, and the length of the shadow, this is the length of the shadow. So the shadow of an electric pole, this is the electric pole, of an electric pole was 75 root 3 meter. Okay? And the shadow, if we're talking now, this is the shadow. If this is the electric pole, now if it casts, now the shadow on the ground becomes what? 75 meter long. Determine the angle of elevation of the sun. And if this is the sun, and this is the top of the pole, this is the shadow. The angle of elevation here becomes what? Theta. So if the angle of elevation there is theta, now what is the relation here? This is our opposite, this is our hypotenuse, and this is our adjacent. So what relation gives us opposite and adjacent? That is tan. So this becomes tan theta is equal to what? Opposite over adjacent. That's your TOA. So this is what tan theta is equal to, your opposite here gives you what? 75 root 3. The adjacent here gives you what? 75. So 75 cancels 75. So I'm having here that tan theta is equal to what? Root 3. So theta here, if your tan comes over, that becomes your tan inverse. Tan inverse of what? Root 3. Your tan inverse of root 3 is going to give your tan is equal to 60 degrees. So give me your tan at 60 degrees, and that is your final answer. Now, we have a question here. A schoolboy lying on the ground. If the ground, this is where the schoolboy is. Let's say it's lying in point A. The schoolboy lying on the ground, let's say that point is point A, 30 meters away from the foot of a water tank. Okay? Now let's say this is the water tank. Let's say this is the water tank. So the boy is lying 30 meters away from the foot of the water tank. Observes that the angle of elevation of the top of the tank, an angle of elevation from the top, from these points to the top of the tank, is 60 degrees. Okay? Now what they asked us was, calculate the height. Calculate the height of the water tank. Let the height be x. Now what is the relation? This is our opposite. This is our adjacent. Our relation here is going to be what? Tan theta is equal to opposite over adjacent. So tan 60 degrees is equal to, your opposite here gave us x over 30. Now tan 60, according to your special angles, is going to give us root 3 is equal to x over 30. So at this junction, cross multiply. So the x times 1 gives us x. 30 times root 3, that's going to give us 30 root 3 meter. And that is your final answer according to the question that came out in JAM 1995, question number 35. Now, this is a typical example of a modern WAEC question from your past question, WAEC 2013, question number 13. Now, they said, when one end of a ladder is placed against a vertical wall, okay, at a point of 5 meters above the ground. If this is the wall, and one end of the ladder is placed here, 5 meters above the ground, 5 meters above the ground. Now, the ladder makes an angle of 37 degrees with the horizontal ground. Makes an angle of 37 degrees with the horizontal ground. Now, the first thing they ask us to do here is to what? A, represent this information in a diagram. So we've answered question A. We just represented this in a diagram. Now, what is the next question? B said, calculate, correct to 3 significant figures, the length of the ladder. Let the length of the ladder be y. Let the length of our ladder here be y. Now we proceed. what is the relation? We have here opposite, and we have here as what? Hypotenuse. Opposite and hypotenuse, this is what? This relation is what? Sine. Sine theta is equal to your opposite over hypotenuse. So I proceed, this is sine, my theta here is 37, is equals to y over, 5 over y. So at this junction I cross multiply, so I'm having what? Y sine 37 is equal to 5. So y here is equal to what? 5 over sine 37. That is 5 over, what will sine 37 give us? Sine 37 is equivalent to 0.6018. So y here is equal to what? 5 divided by 0.6018. Now that is going to give us, what? 8.30. Now what did the question say? Well, that's 8.308. Now the question said what? Correct to 3 significant figures. So 1, 2, 3. So this is y here is equal to 8.31 at what? 3 significant figures. So we just answered what? Question B. Now, question C, which is the main question, then says, so question C then says, if the foot of the ladder, now, this is the original diagram from the question. Okay, hold on. This is the original question. Okay, let's take the diagram like this. 37 degrees, 5 meters. Now, the question says that if the foot of the ladder is pushed forward by 2 meters. Now, let's say the total distance of this, let the total distance here be k. So if my total distance, let's take a bigger diagram. If this is our diagram, and we have this, we have this. Now, so I say if the total distance from this position to this position is k, the total distance is k. Now the question said, if the foot of the ladder is pushed towards the wall, this is the wall, don't forget this is your wall, 5 meters, is pushed towards the wall by 2 meters. So they move the foot to this place. Which is what? 2 meters. Which is 2 meters. So from here, we're not going to have a new diagram. So we now have what? A new length of the ladder. Because if you move your ladder forward, definitely it's going to go higher. So the answer what? Calculate the what? To nearest degree, the what? Angle which the ladder makes with the what? Ground. Now, calculate what? Theta. Now, finding your theta here is what? An easy task, but you have to put 1 or 2 things into consideration. E.g., putting your k into consideration. Now, don't forget, I told you from the onset that the total distance from this end to this end is k. Now let us find the value of k. Let's find the value of k. Now look at this relation. Look at this. We have here as k. Now we now have our what? Our y. We have our y from this to be what? 8.31. So let's find our value of k. Looking for our value of k, what is the relation? We have here as adjacent. We have here as hypotenuse. That is cos. So cos what? What is the former angle here? The former angle here is what? 37. So what? Cos 37 is equal to k over 8.31. Now, our cos 37, what is cos 37? Cos 37 is equivalent to 0.7986 is equal to k over 8.31. 1. So at this junction, we cross multiply. We cross multiply. So cross multiply, this becomes that k is equal to 0.7986 multiplied by 8.31. So if you multiply that, that's going to give you, a k is now going to give you 6.6366. Now, having gotten this value, that is not the final answer, but it has, we've been told that we've gotten our full value of k. So since we have our full value of k, we're going to what? Proceed to, okay, now, since this total, our total k here is 6.63. Now, they told us that what? The ladder must move forward to cut out 2. So if we cut out this part, then the remaining part here becomes what? The remaining part here becomes your k minus 2. And k minus 2 becomes 6.6366 minus 2. That is going to give us 4.6366. Don't forget, this is what? A meter. Now we cannot go forward. Going forward, what are we to what? Find? What are we to find? Now, we are asked to find what? Well, we're dealing with the new triangle, triangle given. We're dealing with the new triangle. Now, this position here is your k minus 2, and k minus 2 is 4.666 what? Okay, now this is the 4 point. Now don't forget, we found the length of our what? Ladder. So the length of our ladder will not increase. So that is the same length with this what? Ladder. So now we are now going to look for what? Solve for what? The new angle. Now we have here as theta. Now this position here, this is our 4.6366. Now our length of our ladder is constant, which is our 8.31. So at this position now, what is the relation? This is our opposite. Now this is our, the relation here is what? Cos. So cos theta here is equal to adjacent over hypotenuse. So cos theta here is equal, what is our adjacent? Our adjacent here is 4.6366 over, our hypotenuse here is 8.31. So cos theta here is equal to 4.6366 divided by 8.31, which is going to give us cos 0.5579. So at this junction, theta here is equal to cos inverse of 0.5579. So the cos inverse, you press your shift, then your cos. That will give us the cos inverse. So our cos inverse then gives us theta is now equal to 56.08 degrees. But the question says to the nearest degree. So to the nearest degree, our answer is equal to 56 degrees. So that is the answer to this particular question. So we've been able to find A, which is representing the information in diagram. We calculated what the length of the ladder. Then we have what a little manipulation into the question, and which we dealt with, and we have our answer correctly. Now we have another question here. So a man 1.7 meter tall. So if this is the man 1.7 meter tall, okay, now this is the man, this is the head, this is his leg, okay. So he observes a bed on top of a tree. Now if this is the, don't forget, this is the ground. So, and this is the what? This is the tree. So the man, okay, here is it. He observes a bed on top of a tree at an angle. If he's looking, this is his head, he's looking from his what? His eyes. He observes what? At the top of a tree at an angle of what? 30 degrees. At an angle of 30 degrees. Now, distance between the man's head, this is the man's head, and the bed. The distance between the man's head and the bed is what? 25 what? Meter. Calculate the height of the tree. The total height of the tree from the ground to the top becomes what? X. Now don't forget, if this man is what? 1.7 meter. So up to this point, this point 2 is what? From here to here is also what? 1.7 meters. So what are we left to find now is what? The height from this place to this place. Then we can now add it to 1.7 meter to give us the total height of the what? Of the tree. Now this part here, let's call it, so this part here becomes what? This part here is the what? Our x. So here our x here, this is what? Opposite hypotenuse. That's sine. Sine 30 degrees is equal to x over what? 25. So sine 30 degrees is equal to 1 over 2 is equal to x over 25. So cross multiplying, this is what? 2x is equal to 25. So x here is equal to 25 divided by 2. So x is equal to 12.5. So if from the man's head upwards is 12.5, now plus the man's length, the addition of both is going to give us what? The total length of the tree. So the total length of the tree here, total length of the tree, total length of the tree is equal to what? 1.7 plus 12.5, which is going to give us 14.2 meter, and that is our final answer. Okay, so going forward, a boy 1.2 meter tall stands 6 meters away from the foot of a vertical lamp pole. This is the boy. This is the boy. 1.2, okay. Let's take the diagram again. This is the boy, 1.2 meter. Okay. He said it stands what? Okay. It stands 6 meters away from the foot of a vertical lamp pole. Now this is the lamp pole. This is the lamp pole. He stands how many meters away? 6 meters away. Okay. Okay. 6 meters away from the foot of the vertical lamp pole. 4.2 meters. Now the vertical lamp pole is 4.2 meters. They said if the lamp is at the tip of the pole, so let's say the lamp is what? At the tip here, at the tip of the pole. So represent this information in the diagram. Now this is the boy here. So we have this. We have this and we have this. So this is the boy. So if here is 1.2, here is also 1.2 meter. So now the one further said, calculate the length of the shadow of the boy cast by the lamp. Now this is the lamp here. This is the boy. So the boy's shadow is going to reflect on the ground. So this is the boy's shadow. And this is what? His shadow, reflecting from his head to the ground, caused by the lamp. But now we cannot find this shadow if we don't know the internal angle. We have to find our internal angle first, which is what? Theta, before what? Being able to find it. So we have to find what? Solve for what? II first. And what does II tells us? II said the angle of elevation. Okay, the angle of elevation. We'll have a repetition here. So I cancel this. So the angle of elevation of the lamp from the boy. So angle of elevation of that is the theta here. From the boy corrects to what? To the nearest degree. Now, having this, we now have here as 6 meters. We have here as this. So let us calculate what? The value of what? Let's use what this and what this to what find what the value. So this becomes, now if you notice the instruction from this question said that what the length of the pole is 1.2. Now if this point is, now to find this upper part, it becomes what 4.2 minus 1.2. That is going to give us what 3 meter. So 3 meter. So we're able to use this 3 meter to solve. So this because what is the relation? This is opposite. This is what adjacent. That's tan. So we're having the relation tan here. It becomes tan theta is equal to 3 over 6. So your tan theta here is equal to what 1 over 2. Your theta here is equal to tan inverse of 1 over 2. So theta here becomes tan inverse of what 1 over 2. That's going to give us 25.56 degrees. Now they asked us what? Correct the answer to the nearest degree. So that is equal to what? Our theta here is equal to what? 26 degrees to the nearest degree. Now, having found 26 degree, now let's what? Continue. Now, so since we've gotten our value here as our 27 degrees, now let us find the value of this place. So that if we call here beta, so this becomes alpha plus beta plus what? Don't forget this is a right angle, that's 90 degrees is equal to 180. So this thing becomes what is that? Beta here is now equal to 180 minus 90. What is our alpha? 27 minus 27. So beta here is equal to 63 degrees. Now, having gotten our beta here, this angle here to be what? 63 degrees. Now we'll proceed. Now, what is the first question? The first question here says, find the length of the shadow of the boy cast by the lamp. So, casting by the lamp, we're going to be using this what? This angle here, our beta. We're going to be using our what? Our beta here. So, using our beta, yeah? Using our beta. So, this will give us, they said, let's take question. Find the length of the shadow of the boy cast by the what? Lamp. Now, find the length of the shadow. Now, we have what? This here. We're using this angle here. Now, down here, we're going to be using this value here. And what? And what? This particular side. So, this becomes, this bottom here. Don't forget, this bottom here is 6 meter. Now, we don't know the what? The shadow. We don't know this shadow. Because the shadow is what we're looking for. So, this is going to give us what? Tan. Tan theta is equal to opposite over what? Adjacent. Now we have what? Tan. Our theta here is giving us what? 63. Tan 6. Please don't tan theta, tan beta, please. Because our beta is 63. Is equal to, what's our opposite? 6 meter plus what? Shadow. All over our adjacent. Our adjacent here is what? 4.2. So tan 63 is going to give us the value 1.9626 is equal to what? 6 meter plus our shadow, which is S, over what? 4.2 over 1. So at this junction, cross multiply. This is 4.2. So cross multiplying, this becomes 6 plus what? S, which is our shadow, okay, 6 plus our shadow, is equal to 1.9626 times 4.2, which is going to give us 8.2429. So having this, what I'm going to do, collect like terms. So shadow here, our shadow here is now going to be equal to 8.2429 minus 6. So if we're subtracting that, what is it going to give us? Let's continue here. That is going to give us that our shadow our shadow here is equal to 2.2429. So the answer to what? Okay, let's correct it what to the nearest what meter. That is going to give us 2 meters. So our shadow here is equal to 2 meters. With that, we've been able to what? Find the solution to this particular question. So from the top of a building, 10 meter high. So if this is the building and this building is 10 meter high, okay, the angle of depression of a stone, now let's say this is the stone here, so from this top to this stone, the angle of a depression, so the angle of what? Depression of a stone lying on the ground is, now what is the angle of depression? We'll have this out here. Now, in your angle of depression, it is quite different. If you mark in here as 69, you will be wrong. So, you mark the external with your what? Upper part. Now, this imaginary part, so this becomes what? 69 degrees. So, they say, correct to 1 decimal place the distance of the stone. Now, this is the stone, and this is the what? The building. So, they say what? Okay. Calculate the what? Okay, correct to 1 decimal place the distance of the stone from the foot of the building. So this is the foot of the building and this is stone. So let's find here as x. Now, if this is 69, here is also what? 69 degree, which is alternate what? Angle. So having this as 69, we can now use this to solve. So if you don't use this to solve, you can use this because here this is a right angle triangle. You can call here what? 5. And when you call it 5, it can be, you can say 5 plus what? 69 is equal to what? 190. So then you can now say your 190, is equal to 90. You can now say 90 minus your 69, which is going to give you what? Your value of what? 21. You can use 21 here to solve. You are going to get your final answer, or you use 69 to solve. You're going to also get your answer. But in this question, I'm going to use 69 and what? 21 to solve simultaneously. So if we're solving with this, what will be our relation? This is our opposite, this is our adjacent. So this becomes tan 69 is equal to 10 over x. So this is what? X tan 69 is equal to 10. So x here is equal to 10 over tan 69. So x here is equal to 10 over tan 69. Tan 69 gives the value of 2.6050. So we cannot divide. So 10 divided by 2.6050. So that gives us a value of s is equal to 3.8. Don't forget they said to 1 decimal place. So 1, so 3.8 what? Meters. So having gotten 3.8 meters, I said we're going to solve this simultaneously with 69 degrees and with what? 20, with our alpha here, which is what? 21. Now, I said we're going to solve it simultaneously with this angle here. Don't forget that this internal angle here is 21. So solving with this, we are using this relation. That's also tan 21 is equal to x over 10. Now what is my tan 21? Tan 21 is equal to 0.3838 is equal to x over 10. So cross multiplying. So x here is equal to 0.3838 times 10. That's going to give me what? 3.83. Okay, that's 3.83 what? Meters. So we have what? The same thing as our final answer. So whichever way you want to attempt your question, you're always fine to attempt that way. Just make sure the process is correct. Now, an erected what? electric pole, this is the electric pole, 7 meter high, okay, 7 meter high from the ground, it casts a shadow on the horizontal ground when the altitude of the sun is what? 60 degrees. So this is, let's say the sun is shining from this. So when the altitude of the sun is what? 60 degrees, casts what? A shadow to the ground. So what are we left with here? So they say, well, calculate the what? The length. Calculate the what? The length of the shadow. So this is the position of the what? The length. So let's call the length what? X. So at this junction, you can what? You can use two approach to solve. So you can find this internal angle here to be 5. So it will be what? Alpha. Alpha plus what? 60 is equal to what? 90 degrees. So alpha here is equal to 90 minus 60. So alpha here is equal to what? 30 degrees. So since here is your 30 degrees, we can use that to what? Evaluate. So call here our 30 degrees. For this right angle. So what's the relation? This is what? Tan. So tan 30 is equal to x over 7. So tan 30 here is going to give us root 3 over 3 is equal to what? X over 7. At this junction, we'll cross multiply. Cross multiply, this becomes 3x is equal to 7 root 3. So divide both sides by 3. So 3 cancels 3. So x here is equal to 7 root 3 over 3 meter. So you can use the other way to solve. If you use the other way to solve, you'll be able to find your answer too. Now, we have another question here. The question here says, the angle of depression of a boobs from the midpoint of a vertical cliff. Now this is the cliff. This is the cliff. Now, if this is the cliff, so they said the midpoint, that is the middle, right? So they said the angle of depression of a boat from the midpoint of a vertical cliff. So angle of depression from midpoint of a vertical cliff is what? 35 what? Degrees. If the boat is 120 meter away, so if the boat is 120 meter away, so let's say this is the boat here. So this is the boat, and this is the cliff. Okay. Now calculate the height of the cliff. Calculate the height of the cliff. So let's say here is what? X. Now we have this. So this is also what? 35 degrees. So having this as 35 degrees, now we can now what? Proceed with our what? Solution. So if we are looking for height of the cliff, don't forget this is the height. Now we have our cliff. Now let's proceed. Solution. Now we're going to solve this question with the known part. Now what is the known part? Let's find S here. This is what the known part, right? We have our internal angle. We have this. And don't forget, they said what? That if the boat is 120 meter away, that is what? 120 meters. So we have two known parts here. This is the what? The opposite and the what? Adjacent. So what relation is the opposite and adjacent? That is your what? Tan. So tan 35 is equal to x over 120. So at this junction, we'll cross multiply. So tan 35 here, so cross multiply is what? X is equal to tan 35 multiplied by 120. So x is equal to, what is our tan 35? Tan 35 is equal to 0.7002 multiplied by 120. So our x is equal to what? 84.02. So if my x is 84.02, now don't forget, they said what? They made a very powerful statement in the question, which they said The angle of depression, they both from the what? Midpoint. If from here to here is 10, the midpoint is going to be what? 5. So what is, I have 5 meters here, I have 5 meters here. So the midpoint is the center. So if from here to here and it's cut at the midpoint, if the midpoint, one side is 84, then this other side is also what? 84.02. So conclusively, so I can now say, I can now what? Make this decision. Making this decision of saying, so this becomes my addition of my x and my x, that is 84.02 plus 84.02. So that's going to give us 168.04 meter, and that is what we have here as our final answer. So in conclusion here, we have our assignment. This question from the question of angle of elevation and the question from depression. So we have them and the answer in green. The answers, so you practice them and try as much as you can to practice more questions.